Hi, my name is Joel Fernandez, and in this video I'm going to try to explain how Kadane's algorithm works. So Kadane's algorithm is an algorithm to find the maximum sum subarray within an array. So basically we have an array with a bunch of numbers in it, and we have to find the maximum sum subset of that array, such that the sum of all the elements in that array are the absolute maximum. For example, we have an array here, and we have 6 elements in it, and the maximum sum subarray in this array is 2 through 5. So we have 3, 4, minus 5, 6, which sums to 8. So this is the maximum sum subarray that we can have in this array. For example, 2 and 3 is not the maximum sum because its sum is 7. So the maximum sum subarray is 2 through 5 with a sum of 8. So Kadane's algorithm is a linear time algorithm to find the maximum sum. So it does the whole thing in one sweep. So you go through the whole array at once, and in the end you will have the maximum sum subarray. So it's a very clever algorithm. So we have a couple of variables here that we need to use in order to arrive at our result, and we also have a structure that we define to kind of represent a subarray with its total sum. So I is the start of the subarray, j is end of the subarray, and sum is the total sum of the subarray. So that's kind of a unit of a result, of what makes a result, which is a subarray with a certain sum. So all these variables are of type result, and in fact this is supposed to be max sub, which is an array in its own right. Max sub is an array which contains the maximum sum subarray at each element. It kind of says that, okay, at this particular element, starting from the beginning, the maximum sum subarray is this. So basically it keeps track of at each element what is the maximum sum subarray so far. Okay, so that's our result. The max variable is a variable that keeps track of what is the maximum sum subarray that we have seen so far, starting from the beginning. So every time we see a better result, a better subarray, we update the max. So it's very simple what max is. Max cur is to keep track of the current maximum subset, maximum sum subarray. And its purpose will be clear in some time. So basically the reason for max cur is that as you go over the elements one by one, at a particular point of time you'll have to discard all the old elements and restart. For example, if the sum as you perform your sweep falls below 0, then you have to throw away all the ones in the beginning, from the beginning. So that's what max cur is for. It's very hard to explain what it does, so I'll start with an example, and that should make things more clear. So we start with the first element, I is equal to 0, and I have some code here which I'm going to explain how it works. So we start with the first element, and before we did that we actually set max cur and max to negative infinity. So we kind of did that here, max and max cur to negative infinity. It's kind of a good idea to set the max variables to negative infinity because they get updated later. And we start with the first element. We look at it, it's minus 1. It's better than the current maximum sum subset. So we update max cur with minus 1, and we set its interval to 0 and 0. Okay, so what happened was max cur is negative infinity. We see that the current element is greater than the sum that's represented by max cur. So we update max cur to be the current element with an interval of 0, 0. And after that what we do is we update the max, because minus 1 is better than negative infinity, so we update the max. And at the end of all this, we update the result is made to be the max entity. So the result for the current element is the max. Then we go to the second element and we see that it's -2. So we notice that the current maximum sum subarray, the current maximum sum that we have been accumulating is -1, and that's actually below 0, so it cannot possibly help us with anything. So if we were to add ourselves to a negative number, we would get more negative, which kind of does not help us get a maximum sum. So what we do here is we throw away whatever's in maximum curve, which is -1, and we just take whatever's in a of 1, which is -2, and we include it in maximum curve. So this becomes -2, and we set the interval to 1, 1. So again, the reason we did that was adding -2 to -1, it gave us -3, which doesn't get us a better answer. So we don't include -1, and we reset the current maximum sum subarray to 1, 1. And we look at the max. We try to see if we are greater than max. We're not greater than max, so we let max be the same thing. And then we say, okay, what is the maximum sum subarray that you've seen so far? And that's our result. So we set that to -1, 0. So note the difference between the max that you have seen so far from the beginning of there and the current max. Okay, so current is kind of reset every time we accumulate below 0. So now we go to the third element, and this should make things more clear. And we see, again we do see the same thing. Maximum current is -2, which is below 0. It cannot possibly help us. So we have to reset the current maximum sum subarray to the element itself and reset the interval to the index of the element. And after we did that, we look at max, right? We look at max, and we see that we're better than -1. So we update max. And as always, we set the result to whatever is in max. And we go to the third element, or fourth element rather, which is 4. And we see that maximum current is now positive, so it will definitely help us. So we execute this else block, and we add ourselves to maximum current. So we add 4 to 3 and we get 7. And at the same time, we also update the interval to now be 2, 3. Because we included ourselves in the interval, and we got a better sum. Then we look at the max, and we see we're better than the max. So we set the result to be the max. Okay. Now we go to the next element, which is 4. And I is equal to 4, which is the fifth element, and that's -5. We look at maximum curve, and we see that it's positive, so it will help us. So we add ourselves to it, and we get 2. So we're here right now, and we update this to 2, 4. We update maximum current to 2, 4 because we included ourselves in the interval. Then we see we're better than max or not. No, we're not better than max, so we set max. We leave max at 2, 3. And as we should, we set our result over here. We set our result to 2, 3. Finally, we look at the last element, and we see that max current is positive. So we say that, okay, it's going to help us increase our current maximum sum. So we add 2 to ourselves, which is 6, and we get 8. And now the interval becomes 2, 5 because we included ourselves in it. Then we look at the max, and we see that we are better than the max. So we set max to whatever we are. And we set result to the same. So basically what I've shown you is that the maximum the maximum sum subarray is 8. So at the last element we look at the result and we know that that is the maximum sum subarray that we have seen in the entire array. So the answer is 8, 2, 5. So we did the whole thing in linear time, which is really cool. Thank you.